In this video, I'm just going to continue. This is video number 2, which I'm going to continue on Modbus function number 4, how to read an input register. In actual fact, it's reading a single input register. But yeah, let's go over to the program. As I've said, I'm just going to continue from here. So we've seen in the previous video, as soon as the whole message is received from the master micro, the counter will actually stand at 6. Indicating that 6 elements were received, and also Rx array will be at the element number 1 will be a 4. So if I can scroll down here, you will see that's my number 1, that's my number 2, this is number 4. So this is what I've set here. So Rx counter will be at 6, as well as element number 1 of Rx array will be at 4. Indicating that I received a message from the master microcontroller, which is in actual fact for function number 4. So in this specific case, remember, I've received a value from the master microcontroller, which is in actual fact, it was actually 299. Let me just clear this. It was actually 299, which is 1B, 12B rather. So if I take that and I say input address is basically will be what sits at receive array number 2, which is moved 8 positions to the left. That means I'm actually capturing the 0, 1. This is the one I'm talking about, the 0, 1. I'm capturing that one there. And in element number 3, this is in element number 3 of the receive array, that is where we will find the 2B. So I'm actually combining, by doing this step here, I'm just combining 2 bytes together, which will be consisting of a value if I requested from my master microcontroller for address number 300, I will be sitting with 12B, which is 299 in input address. So now if I increment input address by 1, I'll actually sit with a value of, if I say plus 1 is equal to 300 in decimal, which is 12C. This is what I will be setting in input address after this statement. Here we are just again resetting the counter, and now we're going to start loading the value that should be transmitted back from the slave microcontroller number 2 to the master microcontroller. So the slave here, I could have said just 02, but I'm just taking what was received, because this is the response back from slave number 2, slave micro number 2. We are responding on number 4, and the bytes that will be sent back will be 2 bytes in total. So as I've said before, I have created an input register array, basically an array of integers by the name of input reg. And now you know, we've seen already that the input address here is a value of 300. So if I put 300 in here, minus 300, I'm actually sitting at value of 0. And if you can recall, I have said that in this input reg, element number 0, that is where I am placing element number 0. This is where I'm placing my value, which is coming from my ADC. So at address number 300, I'm actually going to input reg element number 0, and this is where the ADC value will be sitting, and this is what I want to capture. So I've created here an input pointer by the name of input, and now I'm going to say well, in this specific case, the maximum value that can be in input reg, depending on what my scaling factor is. In this case, it's a value of 110. Now, if I can just quickly go back to this again, and I'm saying this is 110, I will actually sit, oh sorry, it's actually decimal, 110. I will sit with 6E. That will be, if it's the maximum value, 6E will be sitting. It's actually 006E, which will be sitting in input reg element number 0. There will be 006E. So if I do this and I say, okay, put the value pointed to by input, and take that value and also move it 8 positions to the right. This is the high value that I'm actually storing, which is actually 0, 0. And if I just take the value pointed to by input, I will then only actually capture the low byte and send the low byte in element number 4. So again, my slave here microcontroller will send 5 from 0 to 4, which is 5 bytes. And here I'm just again making sure that the data register of the UART is empty. I'm sending that, I'm first of all sending element number 0, and then element number 1 up to element number 4, and that will be transmitted back to the master microcontroller. So the master microcontroller gets the message. It is number 2 responding. It is responding on function number 4. 2 bytes will be sent. Here I'm loading 0, 0 and 6E if, of course, the maximum value is 110 decimal. Otherwise, it could be anything. So you will see, I'm also going to show you that I'm going to change the value in my ADC section, and I'm basically going to measure a value of 5000. And then you'll see that it will also transmit the whole value back to 2 bytes. In other words, one integer. It will transmit that back to the master microcontroller. But yeah, as we've seen before, all I do on this slave microcontroller number 2 is I'm just placing a value of 4 there just to indicate it was function number 4 that was addressed. And here I'm just clearing the receive array again. Good. On the master microcontroller, of course, again, there's also this UART receive interrupt vector or interrupt handler. And yes, what will happen here is, again, just like before, the data will come in. It will be stored into this receive array. The counter will be incremented, etc. And at some point, remember, we've sent from this slave microcontroller number 2, we have sent 5 of them, and it was function number 2. So I've sent 5 in total, and it's function number 2, sorry, not 2, function number 4. Good. So let's get here. So at some point, I'm just checking now where will RX counter be 5. So let's scroll down. There's one of them, but it's not number 1. So it will be this one here, where the counter is 5, and the receive array will actually contain element 1 contains a value of 4. So this is the message that will be received by the master microcontroller. So all I'm doing here then is in element number 4, as you can see from that was transmitted, element 4 is the low value, is placed on port B of my master microcontroller. I'm placing that on port number B, and on port number C I'm placing the higher byte value, which was transmitted by, this is slave number 2. So, and this is coming, it's actually placed on element number 3 here, and I'm placing that higher byte there. So port B shows the lower byte, and port C sort of, well, a portion of the upper byte, because I'm not using all the bits in port number C. So if I can just remove this, let's just make sure, let me bold this one, and let me bold this one also. Both of them are basically succeeding. And if I now go to my Proteus design, remember I have, in this specific case, if you look at this maximum scaling factor will deliver a maximum value of 110. So let's see, which is 6E. Let's see if that's going to happen. Let me start this thing again. So the master sent the message. The slave will respond on that message. And what do we see here? 110 is 6. 1110 is E, so that's E. But it's continuously reading this, of course. If you look at these color changes here, you'll see that it's constantly transmitting, receiving, transmitting, receiving. So if I change my input here, you will see also that on the master I can see the change. If I change it back to maximum, which is 5 volt here, on the input of this ADC 0, it will be again go up to 6E. So it shows exactly that this device is showing an analog input value of 110 decimal. So I'm just going to quickly, I'm almost done with this video, I'm just going to quickly change the scaling factor here, so that if what if we say, but I want to measure a tank in liters of up to 5,000, for instance, let me change that. Then I want to see up to 5,000 also being displayed on the master microcontroller. So let me just do something here. I just want to show you if 5,000, let me just clear, 5,000 is actually 1388. So let's see if that is what we get. Let's go to this Proteus, let's start again, and now it's still at maximum, but now the scaling factor has changed. And if you look at this one here, remember this 4 bits work together, this gives us a 3, that's a 1, so it's 1, 3, and please remember you must ignore this first 2 because they're not connected, and that's 1000, that's 8, and that's 1000, that's also 8. Né? So if we look at this, 5,000 is 1388, which is exactly 1388 what we see. And again, if I change the value here, you will immediately see the change also happening on this master microcontroller outputs. So yes, this function number 4 works perfectly, where the master requests from the slave what is the holding register value, in this case at address number 300. The slave responds back, and I can see that value there. And here you can see the specific, this is just indicating that it is this is function number 4 being responded to. That is it. I hope that you enjoyed this video, and this gives you a lot of insights into this specific function. Thank you.